All right, this should be our last recording. Okay, so here's one of my favorite problems. It's the prairie dog problem. Okay, and prairie dogs are very good at burrowing, and so they understand. They understand if they make this opening higher and thinner than this opening. I mean, I think they took a physics class, back in prehistoric ages. But anyway, um, they understand that what happens is this will create a low pressure here, high pressure here will create a pressure difference that will blow the air pressure through here. So you get this ventilation system going. So if you want to ruin their day, make this wider, and then they get no air and they suffocate down there when they're sleeping. But no, we shouldn't say that. But I mean, yeah, cute little prairie dogs. Hey, you be a wheat farmer or you be a cattle rancher out in western Kansas. You tell me about how much you love prairie dogs. But anyway, um, uh, so I mean, everything's got a trade-off, right? So here we go. So this is a Bernoulli problem. It's a Bernoulli problem. So we've got this down. We know how to do this. So let me show you how to set this up. So here we go. We just go to here's the prairie dog problem. I got to go back already because the V1 VA is equal to 8.5 meters per second. VB is equal to 1.1 meters per second. And the density of air throughout the problem is 1.29 kilograms per meters cubed. Okay, good. So now let's take a look at what we're doing here. Here's what we've got. All right, so, and they had this opening here. This is the thin opening. Okay, it goes along. We got this little bulge here. There's a little bulge here. And we got this bigger opening here that should actually be lower. This big opening here. So this is 8.5 meters per second is blowing here. 1.1 meters per second is blowing here. This is P1. This is P2 that we're going to be measuring. So the air pressure here, P1, plus this moving air of 1/2 rho 8.5 squared plus rho GH. Now, we're going to assume that they're on the same level. So we don't need that one. Is equal to P2 plus 1/2 rho 1.1 squared. All right, so it looks like it'll be easier just to go ahead and get the change in pressure over, bring P1 over here and bring this one over here, just because this is 8.5, this is 1.1, so it doesn't make a difference, right? We just need the change in pressure. So P2 minus P1 since we subtracted P1 from this side, subtract it over there, and then we're going to subtract 1/2 P1 from over here. So we got 1/2 rho times 8.5 squared minus 1.1 squared is equal to the change in pressure. And that's what they're after, is the change in pressure. So so it's not hard. The Bernoulli thing's not hard, and it's really cool. So, and in fact, your last problem, what was this, problem 61? So then your last problem was like this. All of a sudden I went to a black pen, didn't I? All right, so your last problem is like this. This is problem 63. Here's the airplane wing problem, and we've already talked about this. Notice again, the heights are going to be the same, but we're talking about the lifting force. Now, we talked about the lifting force earlier in the notes, which are pretty extravagant. In the wing, when we were first talking about the Bernoulli equation, I could have swore I wrote down this stuff about a lifting force. What did I do with it? Oh, here it is. Gosh dang it. Right here. Here's your wing lifting force problem. We said the heights were about the same. So you got this force over the area. So you're going to find the change in pressure, and then you solve for F. Solve for that force. Easy. Easy peasy. All right? So have fun with this stuff, and I will see you tomorrow. Some of you probably aren't watching this until well after tomorrow, so well after Tuesdays. But anyway, I hope you do. I hope you did get a chance to see this. So as disjointed as it may